Friends, welcome to my channel once again. In the last lecture or in the last video regarding the stationary waves, we have seen about the analytical treatment, but for the pipe open at both the ends, or we can see the string open or string free at other ends. Now in this particular video we will see when a string is fixed at other end, that means both the ends are the string is fixed or are fixed, right. So here let us start this video. Consider a simple harmonic wave given by the equation, because we know that the simple harmonic wave in general we can write y is equal to a sine 2 pi by lambda Vt minus x as it is shown in the screen, right. So now again we know that, as we have taken in the previous video also, one is what the incoming wave or incident wave and one is what the reflected wave, because we know that the stationary wave is a combination or the superposition of two waves which are traveling in opposite direction having same frequency and amplitude. Okay. So first wave, let us consider it is moving to the positive x side and we call it as incident wave, and whose displacement or the particles displacement in that particular wave is taken as y1 is equal to a sine 2 pi by lambda Vt minus x, and name it as equation number 1. Okay, the displacement of the same particle at the same instant due to the reflected wave, because the particle of the medium remains same, but the particle vibrates differently when the reflected wave comes, and with respect to that reflected wave, since the particle are taking the vibrations and now they are in opposite directions, right, and therefore we call reflected wave as y2. And since the wave is moving in negative direction, that is why it is again minus a sine 2 pi by lambda, and here Vt again here, since wave is moving in negative direction, but these particles are taking vibrations due to the opposite direction or reflected wave, that is why here minus, and here since wave is going to or propagating to the negative x direction, that is why this minus, because this is in general formula minus, and this minus x becomes plus. So in short we got for the reflected wave displacement, that is y2 is equal to minus a sine 2 pi by lambda Vt plus x, and that is what reflected wave. So as we have done in case of the first case, similarly here the resultant will be the addition of these two, y1 and y2. That will be the resultant displacement of or corresponding to stationary wave. This is what simply an incident wave, this is also the plane progressive wave was reflected, but combination of them, that means if we add them together, or both the waves which is moving in one direction and another is moving in another direction, opposite direction, they are superimposing on each other, and therefore it forms the stationary wave, and the resultant displacement of that stationary wave, simply it is y1 plus y2. Okay. So this is equation number 1 y1, this is equation 2 which is y2, substitute the values, then we got y is equal to y1 plus y2, y is a sine 2 pi by lambda Vt minus x, kept as it is, plus, but y2 is negative, that is why minus a sine 2 pi by lambda Vt plus x, equation 3. Now again we have to use here the trigonometric addition and subtraction like this. For sin c minus sin d, because a is common, we can take a common, right, and for the sin c minus sin d we have the formula. Let us go to the whiteboard and I will show you what formula we have to use here. So for sin c minus sin, this formula, what is that? 2 sin c minus d by 2 into cos c plus d by 2. Okay. And here in our case, what is c? 2 pi by lambda Vt minus x is c, and what is d? 2 pi by lambda Vt plus x, that is d. So simply that 2 pi by lambda or simply this c we have to substitute at this point and at this point, and this d we have to substitute at this point and at this point. And if we do these calculations again in those c and d, we have one thing common, that is here 2 pi by lambda and 2 pi by lambda. So we can take it as common. So simply c means we can take this by taking common 2 pi by lambda v, and here d means Vt plus x by taking the common 2 pi by lambda. Okay. Now if we substitute all these values, so once again see the formula, sin c minus sin d, it is a 2 sin c minus d by 2 into cos c plus d by 2, write down somewhere, because in that particular topic in the previous video we have seen sin c plus d. So little bit change, but both formulas are different. right. Now, if we go there, the C value, substitute this C value and this D value, substitute here in above formula, and let us see what we get. So, after substituting, what we get is here on our presentation screen. So, what we get is capital Y or the resultant Y, and that is nothing but minus 2a sin 2 pi x by lambda into cos 2 pi v t by lambda. So, some of you have may have the doubt why it is minus, because now this is C and this is D. So, sin C minus D, what we got, the formula sin C minus D is 2 sin C minus D divided by 2. So, 2 sin C minus D means C v t minus x minus v t minus x, okay, or v t, because minus plus becomes minus. So, in this case minus x and minus the plus v t and minus v t get cancels, and what remains is minus 2x, minus x plus minus x, that means minus x that is minus 2x, and divided by 2, that is why it will be minus x. So, what we got here, 2 or 2a as it is, and sin minus of 2 pi x by lambda, sin minus of 2 pi x by lambda. But we know that sin negative angle means negative final result, because sin is a odd function. Sin of minus theta will always be minus sin theta, as we have seen in the previous case. Cos of minus theta is plus cos theta, but here sin of minus theta is minus sin theta, and again here cos 2 pi v t by lambda. You please do these calculations and see, you will find this equation number 4, y is equal to minus 2a sin 2 pi x by lambda into cos 2 pi v t by lambda. Use that formula. Okay. Now, the resultant vibrations of the particle represents a simple harmonic wave of the same time period. The amplitude of the resultant wave is given by, because this is what this resultant wave will have the same time period, but the amplitude has been changed, because for y1 it amplitude is small a, for y2 again amplitude was same, because we know two equal and opposite waves, but whose amplitude and frequency are same, they are superimposing on each other, and then we got our stationary wave. So, the amplitude of this I already told you, in any wave equation only the t part or the term in which t is involved, that is the wave part, and remaining everything is the amplitude. So, here 2a sin 2 pi x by lambda is the amplitude. So, here 2a sin 2 pi x by lambda, this is what the amplitude of that resultant wave, stationary wave. Okay. And yes, from this equation 5 only we can say it is a function of x, not the t. I already told you the function of x only the amplitude, and remaining the function of t is what, the wave part. Okay, right. So, once you got the y, that is displacement, you can find the velocity simply by differentiating it with respect to time. So, do the same, dy by dt, it is what, the velocity, y is what, here equation 4 is y. So, differentiate this with respect to time. So, again here minus 2a 2 pi x by lambda, it is independent of time, that is why only take the derivative of this. So, this cos, and since the derivative of cos is minus, that is why this minus and this minus becomes plus. So, final velocity equation you are getting positive dy by dt, and derivative of this cos is sine, means minus sine, I have taken minus already. So, minus sine 2 pi v t by lambda, and again the derivative of this internal particular theta. So, 2 pi v by lambda. So, here 2 pi v by lambda already, a was there, 2a was there. So, 2 into 2 4, 2 pi a was as it is there, and lambda in the denominator and v. So, 4 pi a v by lambda sin 2 pi x by lambda into sin 2 pi v t by lambda, because cos derivative is negative sign, but already it was a negative here in case of y, that is why that negative and this negative becomes positive. So, this is what equation number 6, dy by dt, which is velocity. Okay. And moreover, which velocity? Particle velocity, right. Okay. The acceleration of the particle at any instant of the time is what, d2y by dt square. Take the derivative of velocity one more time, you will get the acceleration. So, let us differentiate equation 6 with respect to time and keeping x constant. Again here equation, this is what the x term, sin 2 pi x by lambda is constant, and this first factor to 4 pi a v by lambda is also constant with respect to time. So, simply the derivative of this sin factor with respect to time. So, again derivative of sine is cos, so cos 2 pi Vt by lambda, and by the chain rule the derivative of this theta is 2 pi V by lambda. Already 4 pi AV by lambda was there, and again multiplied by 2 pi V by lambda. So, 4 into 2 it is 8, pi into pi square, yes, here A as it is, V into V square, in the denominator lambda into lambda square, sin 2 pi x by lambda as it is, sin 2 pi x by lambda, and derivative of sine is cos, so cos 2 pi Vt by lambda. This is what the acceleration of particle, right. Okay, equation number 7, d2 by d2y by dt square, that is particle acceleration. And lastly, what we know or what we have to find is the strain or compression, which is dy by dx. So, simply differentiate equation number what 4, that is y, with respect to x to find the compression or strain, right. Okay, because finally we are taking the help of this compression term only to decide whether it is a node or antinode. So, let us find dy by dx, that is our strain. So, y is what? Y is already negative, minus 2a sin 2 pi x by lambda into cos 2 pi Vt by lambda, it is equation number 4, and here we have to take the derivative with respect to x, that means this term will be constant, cosine term will be constant, and this minus 2a is also constant. So, simply derivative of this sine with respect to x, it is cos 2 pi x by lambda, and the derivative of this internal theta, that is 2 pi by lambda, but already minus 2a was outside. So, minus 2 and this 2 is 4, minus 4 pi a is as it is. So, minus 4 pi a by lambda, yes, is it? Yes, minus 4 pi a by lambda, cos term, why cos? Because derivative of sine is cos 2 pi x by lambda, and this cos 2 pi Vt by lambda as it is. So, this is what the compression or strain, dy by dx is equal to minus 4 pi a by lambda cos 2 pi x by lambda into cos 2 pi Vt by lambda. Okay. So, these are what the terms we got. What are those? First one is the resultant displacement, that is y, yes, equation number 4. Then we got the amplitude, then we got the velocity, and then we got acceleration, and finally the compression or the strain. Okay. So, now we have to take the positions with respect to two different things, because all these factors depends upon either position or time or both. So, that means we have to see the changes with respect to position and with respect to time. Therefore, first title we will talk changes with respect to position. Exactly similar, in similar manner we have done for the pipe or open end pipe at both the ends, say exactly same, right, but little bit change in the reflected wave, and therefore a little bit change in all equations. Okay, right. So, here changes with respect to position, changes with respect to position. So, in that again consider first position like this, sin 2 pi x by lambda is equal to 0 and cos 2 pi x by lambda is equal to plus minus 1, because we know the cosine and sine have the maximum value plus minus 1 and minimum value 0, and therefore we consider either first time sine is minimum and cos is maximum, or vice versa, it depends on us, no problem. So, sin 2 pi x by lambda is equal to 0 we have considered, and cos 2 pi x by lambda is equal to plus minus 1, because it is we are dealing with the changes with respect to position. So, only the position factor, position terms, not about the time terms, right. Okay. Now, we have to substitute these two conditions in all those 4 equations. What are equations? Our displacement, then amplitude, then velocity, and strain and acceleration. So, from y is equal to 0. Why? Because what is y? Now, look at this. This is what equation 4. In that we got the y is equal to minus 2a sin 2 pi x by lambda into cos 2 pi Vt by lambda. But sin 2 pi x by lambda is equal to 0. So, if I talk about this term, it is 0. That is why y will be 0. If we go to the amplitude, in amplitude again we have sin 2 pi x by lambda term. So, therefore, it is 0, and since amplitude is also 0. Okay. Again, if we go to the velocity, we have sin 2 pi x by lambda term, but sin 2 pi x by lambda is 0, therefore, velocity is also 0. If we go to the acceleration, again in acceleration also we have sin 2 pi x by lambda and it is 0. So, what is that? What we got finally is displacement 0, amplitude 0, velocity 0, acceleration 0, but if we go to the strain, here is the strain. In the strain, we have cos 2 pi x by lambda, not sin 2 pi x by lambda, and cos 2 pi x by lambda, yes, it is plus or minus 1, but already the strain is negative, that is why it becomes minus and plus. So, minus plus 4 pi a by lambda cos 2 pi x by lambda is that plus minus 1, that is why it goes, and then cos 2 pi v t by lambda as it is. So, everything is 0 except the strain. Here we can say strain is maximum, and all other things are 0. So, the maximum strain is present at what? Node, that is the node point. So, the strain is maximum, velocity 0, amplitude 0, displacement 0. From these points also we can conclude displacement 0 means yes, it must be at the mean position, right. The amplitude 0, that means it is again to the mean position. Strain 0, strain maximum, that means it is a node point. Why? Because at the node point, because if we take this example of spring, if I compress the spring, so it is what? Compression or strain. So, that is what the nodal point, if I release it, then it goes to the extreme condition, that will be the antinodal point. But here what we got, the strain is maximum, compression is maximum. So, at the nodal point we have maximum strain or compression, and remaining things are 0. So, we can conclude from equation 9 to 13. So, from these we can conclude it is clear that these positions, displacement, amplitude, velocity and accelerations are 0, but the strain, it is here strain by mistake, but strain is maximum. These positions corresponds to nodes. For this we have considered sin 2 pi x by lambda is equal to 0. So, since sin 2 pi x by lambda is 0, but by the standard formula or by standard angle, sin m pi is equal to 0 for all m. Okay, integral multiple of pi is always 0. So, again if we compare these two equations, we got sin m pi is equal to sin 2 pi x by lambda. If we take the sine inverse, then what we get is 2 pi x by lambda is equal to m pi. And if we cancel the things, pi will get cancelled, and finally we got x is equal to, this lambda goes to the numerator, m lambda by 2. What is x? X is the position where at what position, or this is what the position of that corresponding point. But these points, we know what these points are, nodal points or nodes. So, let us talk about the different positions. If we talk m is equal to 0, then 0, m is equal to 1, lambda by 2, m is equal to 2 get cancelled, lambda, 3 lambda by 2, then 2 lambda and so on. Okay. So, these are what the different positions of the nodes. And if I want to find the distance between any two successive node, just take the difference between any two. So, lambda by 2, this second minus first, lambda by 2 minus 0, it is lambda by 2, lambda minus lambda by 2, lambda by 2, 3 lambda by 2 minus lambda, it is lambda by 2 and so on. So, that means what? The distance between any two successive node is lambda by 2. Yes, that is what I have written here. Thus, the nodes are equidistant and separated by lambda by 2, and at x is equal to 0, the position of the interface is node, because when we talk x is equal to 0, right, this is what the position of the interface or mean position, and at that point we have a node, but yes, it is at the interface, at the boundary, that is the position of the closed end organ pipe or a fixed end of a stretched string corresponding to a node. We got at x is equal to 0, we are getting it is a node. So, at x is equal to 0, what we have? We have either the end of our closed end pipe or another fixed end of our string, if we talk about these two different examples. So, finally, we got the at that particular interface point we have a node, not antinode, right. Okay. In case of open end pipe, if you remember, at the end we had antinodes. So, this is what the difference, right. Okay. So, here we have considered first condition, sin 2 pi x by lambda is equal to 0 and cos 2 pi x by lambda is equal to plus minus 1. Now, reverse second. Now, secondly consider sin is now maximum and cos is minimum. So, from again equation 4 to 8, that means from our displacement, amplitude, velocity, acceleration and strain. So, if you substitute all these value, now here I am not wasting the time, you can just substitute the values of this sin 2 pi x by lambda and cos 2 pi x by lambda in those 4 equations, and we get 5 equations from 4 to 8. So, y is equal to this, it is maximum, amplitude is maximum, that means displacement maximum, amplitude maximum, then velocity is maximum and acceleration is also maximum. So, all things are maximum except the strain. Strain is 0. Strain is 0 because if you remember, only strain contains cos 2 pi x by lambda. Only strain contains, sorry, this is not this one, only strain contains cos 2 pi x by lambda term. All other equation, that means all other factors do not have this term cos 2 pi x by lambda, but that cos 2 pi x by lambda we have considered in this case it is 0. So, therefore, strain is 0, that is compression is 0, all other things are maximum. So, when strain is 0, so that point must be a antinode, right, and all other things, amplitude is maximum, that is antinode, displacement is maximum, it is antinode, right, velocity is maximum, acceleration is maximum. So, that point must be a antinode, and moreover since strain is 0, compression is 0, so it is clear that are the antinodes. Okay. So, as strain is 0, the positions are corresponding to antinodes, and again for this condition what we have considered, cos 2 pi x by lambda is equal to 0. So, cos 2 pi x by lambda is 0 since, and we know that the odd multiple of pi by 2 of cosine is always 0. So, cos of 2m plus 1 pi by 2 is 0. So, these both sides 0 0. So, if we equate left side and take the cos inverse, then we got 2 pi x by lambda is equal to this term, this angle 2m plus 1 pi by 2. If we cancel the things pi and this 2 goes to the numerator denominator in this 2 multiplied and it becomes 4. So, 2m plus 1, we want x position of antinode, x is equal to 2m plus 1 lambda by 4. So, this is what, or this equation will give you the position of different nodes. So, if we substitute m is equal to 0, then yes, m is equal to 0, 1 by 4. So, lambda by 4, m is equal to 1, 3 lambda by 4, m is equal to 2, 5 lambda by 4, then 7 lambda by 4 and so on. Okay. And so, these are what the different positions of antinodes. Since strain is minimum, these points are antinodes and these are the positions of antinodes. And if we want to find the distance between any two successive antinodes, so take the difference between them. So, 3 lambda by 4 minus lambda by 4, it is again lambda by 2, 5 lambda by 4 minus 3 lambda by 4, it is also lambda by 2 and so on. So, thus antinodes also are equidistant and are separated by the distance lambda by 2. So, the first antinode is at, now here yes, first node is at x is equal to 0, but first antinode is at what, lambda is lambda by 4 distance from the mean position or from the first node point, x is equal to 0, or we can say from the close end. At the close end we have node, and then from this at lambda by 4 distance we have first antinode. Yes, right. So, so this is what the changes with respect to or corresponding to positions. So, in the next video we will see the changes with respect to time, because we know these all factors, what is our displacement, amplitude or the velocity, acceleration and strain, all are either depends upon position or time or both. That is why we have to see both the changes with respect to position and changes with respect to time. So, in today's video we have seen the changes with respect to position, and where we got two different points, nodes and antinodes. Moreover, we got exactly from the end point where is the first node, where is the first antinode, and yes, obviously the separation between two successive node and two successive antinode. So, guys, I hope you got this. And if you have any doubt, you can post in the comment box. And if you really feel this video is helpful for your value addition, then like this video, and for more such videos, please subscribe to my channel and press the bell icon so that you will get the notifications of my next videos. Right? Okay. So, thank you guys. Take care and keep learning. We will meet in the next video very soon. Thank you.